Okay, so we talked about amphibians and we talked about reptiles, and we are going to do this warm-up. First of all, the fish, we did this last week. We'll start with just the mouth of the fish, eye. Those hopefully are easy. The fin on the back of a fish is the dorsal fin. The front is kind of spiky and the back is soft. The tail is a weirdly named caudal fin. So I've got mouth, dorsal fin, caudal fin, eyes. There's a flap right here on fish that hides the gills underneath, and now he looks like he has a beard. The flap is called the operculum, and it is hiding the gills, unless it is a cartilaginous fish where you actually just see the gill slits, which would be like a shark. We've got a pectoral fin and a pelvic fin. Pectoral fin is higher, and the pelvic fin is lower. Kind of goes in alphabetical order. And then there's a fin in the back, which is the anal fin. Pectoral fin, pelvic fin, operculum gills, and then the lateral line, which helps the fish detect movement. This helps keep it stable. This is for steering, and the caudal fin is for moving forward for most fish. All right, a difference between a toad and a frog. A frog has wet skin, and it's smooth, while a toad has dry skin, and it's bumpy. What does the word amphibian mean? It means double life. Amphibians spend half their life basically as fish, and in their lifetime they dissolve their gills, grow lungs, dissolve their tail, and grow arms and legs, all in their lifetime, and then they move completely onto land. The scales of a cartilaginous fish, sharks, I didn't expect that you would know this. They're not rounded, and they don't overlap. They're sharp, and they're spread out. So if you, it's like sandpapery, if you pet a shark, it's smooth one way, but if you go the other way, it's rough. And on some sharks, like a great white, it's smooth one way, but the other way is so sharp it'll actually like cut your hands up. And I know that because when I worked at one of my many aquariums, we had shark skin, and the great white shark skin was really, really sharp. Number 5, the 3 classes of fish and an example of each. We have done this quite a few times. Agnatha, chondrichthyes, I'll stick these in your face. I-C-H-T-H, yes. Ost, I-C-H-T-H, yes. Agnatha is jawless, chondrichthyes is cartilage fish, cartilaginous. Osteichthyes is bone. Ost means bone in Latin. These are the 3 classes. An example, hagfish or lamprey. An example of a chondrichthyes is any shark, any ray, any skate, or the ratfish. And bony fish could be anything that is like most normal fish. For each group, tell whether they do internal or external fertilization. Okay, so fish is external. They lay their eggs on a rock, the male comes by and releases sperm. Hopefully the sperm actually gets to the egg in the water, and the eggs are just laid in a rock, and some fish actually defend that little pile of eggs. Amphibians is also external. The female will lay eggs in water, the male will come by and drop off sperm. Knowing this, it's less likely that a sperm would get to an egg with this setup. And also, once the baby is made, it's less likely that the baby will survive. So internal fertilization is an evolutionary feat. It's a better way of doing things. It increases the chances that the baby will actually be formed in the first place, and then it's protected as it starts to develop. Okay, we are going to look at the heart comparison. It is this page in your notebook. You might want to pause it to get to it. And the fish, amphibians, reptiles, mammals, birds, we know when they evolved. This is a really long time ago, 530 million years ago. Their heart is actually only 2 chambers big, which is very much unlike yours. And blood that is deoxygenated or has no oxygen in it yet is blue. And it flows into the heart of a fish, and then it gets pumped out of the heart. So the only thing a heart does is push. It's a shover. So it keeps the blood moving, and it'll go to the gills to get oxygen, and it'll turn red at the gills, and then it just goes straight to the body. The problem is that this is kind of like being on Pirates of the Caribbean ride. You get one shove at the very beginning where you kind of go downhill and catch some speed, but the rest of the ride is really, really slow. So fish are not that efficient or good at getting blood and oxygen to the body cells. So what nature has done is created a second shove, like a second section of the heart, and it's usually right here. After it returns from the gills or the lungs, it'll get a second shove. So what that looks like is a 3-chambered heart, where this blue blood comes in, and it needs to go in an amphibian. It would go to the lungs. And once it moves down here, it does get shoved to the lungs. It actually goes out the back of the top, but it goes to the lungs. And when it's in the lungs, it turns red and it comes back. Instead of going to the body of the frog, it comes back to the heart for a second shove. And it goes back into this chamber and gets shoved out to the body. And I'm just going to draw it like that, even though it comes out the top. It comes out the conus truncus arteriosus. And then from there, the blood will go to the body, drop off oxygen, and come back to the heart. The problem with this is that there's mixing right here. And that mixing in a human would cause huge problems. It's mixing of deoxygenated and oxygenated blood. So this is a 3-chambered heart, and this is only a 2-chambered heart. It's still better because we get a second shove, which keeps the blood moving faster. Then we move to reptiles. Reptiles have one step up from that. They have 3, and then they have like a half wall right here. So the blue blood comes in, comes down here, gets shoved to the lungs, and when it comes back red, it comes into here just like the frog, and it comes into here and then goes out to the body. The better setup is that there's less mixing. So we call this a 3.5-chambered heart. This includes all snakes, lizards, crocodiles, alligators, turtles, all the reptiles. So frogs have a lot of mixing. Fish don't even have a second shove. Frogs have a second shove, a lot of mixing. Reptiles have a second shove to keep the blood moving, but they have less mixing. Obviously, the next step is to make this a full wall, which is what our hearts are like and bird hearts are like. This is a 4-chambered heart. Yes, I'm drawing it as a square. The blue blood comes in, drops into this bottom part, which is called a ventricle, and gets shot to the lungs. And I'm making it goes behind this chamber. At the lungs, it turns red and comes back to the heart for a second shove. There's no mixing, and then this will shoot out to the body. This is the most efficient heart setup, unless we were going to set up something where there's another heart somewhere else in the body to do even another shove. This is a 4-chambered heart. All right, so fish is 2, amphibians is 3. This is 3.5, and this is 4. And if you watch evolution happen, 530, 380, 320, 220 for mammals, and 150 for birds. What you guys are going to do right now is you're going to get what I call a shark book You are going to go to page 480. So in your notebook, you are basically at the very back, and it says Birds and Mammals, get a shark book. It says turn to page 480, birds. And you'll go through birds, you'll draw a bird, and you'll label stuff. The bird does not need to be amazing. What I'm really looking for are the crop, the gizzard, little air sacs, lungs, the four-chambered heart, contour feathers, and down feathers. And of course, it doesn't need to be amazing. By the way, you don't add a mouth here. This is the mouth. Okay. And then you'll also read a little bit about mammals. And we will go over this next class. Your frog dissection is next class. And we are heading towards the end of this chapter and a review before we take the test. This is the notebook you have to get an A on. It starts way back at sponges and jellyfish and the worms. Okay? So you can go grab a shark book. And when you go into the shark book, again, you're going to 480, where they talk about birds, the bones of birds, air sacs, the crop and the gizzard, where they store food in the crop. The gizzard has, sometimes they eat stones, and they'll stick it in this little bubble right here, the gizzard, and it'll grind up the food, so they eat little pebbles. Birds, 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 and then mammals, mammals, mammals. And that's it.